Hello everyone. So I am Mansi. I am from the Department of CSEI from Sri Venkateswara College of Engineering. So today's topic is hidden Markov's model, shortly known as HMM. And in this video, we'll discuss about hidden Markov's model. So let's begin with an introduction. So, hidden Markov's model, shortly known as HMM, is a statistical model that is used to describe the probabilistic relationship between the sequence of observation and sequence of hidden states. It is often used in the situation where the underlying system or process that generates the observation is unknown or hidden. Hence, it's got its name called hidden Markov's model. So, it is used to predict future observation and classify sequences based on the underlying hidden process and generates the data. And HMM consists of two types of variables, hidden states and observations. So the hidden states are underlying variables that generates the observed data, and they're not directly observable. The observations are variables that are measured and observed. So, what are the applications of HMM? That is a hidden Markow's model. So, HMM is used in online handwritten recognition now. So, online handwriting recognitions, speech recognition, gesture recognition, motion video analysis and tracking, stock price prediction, optical signal detection, digital communication, music analysis, and DNA sequence analysis. So now we use hidden Markow's model for predicting the weather of next day based on the current day's weather using hidden Markow's model. So the code is imported imports the NumPy, Matplotlib, and Seaborn and Hemlearn library. So these are the necessary libraries that are needed for the implementation of hidden Markow's model. So the start probabilities, state probabilities, transition probabilities, and emission probabilities are defined as an array. The start probabilities represents the probabilities of starting in each of the hidden states. So the transition probability represents the probabilities of transitioning from one hidden state to another, and the emission probability represents the probabilities of observing each of the output given hidden state. So the initial state distribution is defined as a state probability, which is an array of probabilities. That is represent the probability of the first state being sunny or rainy. The state transition probabilities are defined as transition probabilities, which is 2 into 2 array representing the probability of positioning from one state, transitioning from one state to another. So the observation likelihood are defined as an emission probabilities. So which is 2 into 2 array representing the probabilities of generating each observation of each state. So basically, we are the initial state distribution is defined as state probabilities, and next the state probabilities can be defined as transitioning probabilities, and the observation likelihood are defined as emission probabilities. So first we define the initial state distribution. So state probability is initialized as np dot array 0 0.6 comma 0 0.4, and next we are printing the state probabilities. And next, in the next step, we are just defining the state probability, state transitioning probabilities. So the transition probability is initialized to np dot array, that is 0 0.7 comma 0 0.3 and 0 0.3 comma 0 0.7. So basically we're just printing the transitioning probabilities. So next thing is we're defining the observation likelihoods. So the emission probabilities is assigned to np dot array, which is then assigned to a set of variables, that is 0 0.9 comma 0 0.1 and 0 0.2 comma 0 0.8. So basically now we are just printing the emission probabilities. So the output here, the output of state probability and transitioning probability and emission probabilities are shown. So now we define the observation sequence. So what is observation sequence? And a sequence of observation is defined as one dimensional NumPy array. So the observed data is defined as observation sequence, which is sequence of integers representing the corresponding observation in the observation list. So now we decode the observation sequence. The vertify algorithm is used to calculate the most likely sequence of the hidden states that generates the observation using the decode method of the modeler. So the method returns the log probability of most likely sequence of hidden states and sequence of hidden states itself. So we are using the log probabilities and hidden probabilities. These are assigned to model.decode and observation sequence, and length. In order to calculate the length, we use len function and len observation sequence, and algorithm which is used as vertibi. So next we are printing the log probabilities and hidden states. So the output below is given of log probabilities and most likely hidden states. So now basically we are plotting the graph. Hence we are using Seaborn and PLT plot, which are used to what to plot the graph. And so thank you. Hope you have a great day.